Okay, let me use this diagram to explain a few things again. What I want to say is that each of the area is allocated for the, you know what, I want to use, how about for me to use this as an example? Because I think I explained one, then it's probably okay for you to see the other. Let me use this one as an example. Okay. Okay, the reason I want to draw this diagram is that there is two concepts we need to see um, this diagram. Okay, I'm going to use this. The first concept is called memory layout for the object. Okay, the memory layout for the objects. In fact, it should be this. Okay, objects. And the other one is memory addresses for the member variable. Let me actually make it a little bit smaller. Okay, so I think we agree, right? This is two things we need to figure out. Now let me make it a little bit nicer over here. I think next time I teach the same course, I'm going to use this diagram to explain this a little bit better. Okay. So we have two things, memory layout for the object and then memory address for the member variable. Okay, so let me actually first try to draw a box about where it is for the memory layout for the object. So I really have four different objects in this case. So, oh no, I want to use this one. So I really have four objects in this case. So the first object is account object. The second object is really employee object. The third object is student object. And the fourth object is work study object. The reason I said I have this four different objects and why I need to know their difference is because I mean, with the exception of account object, let me use a different color. With the exception of account object, when I'm handling the other three objects, I really don't know whether that object is a standalone object or is actually part of the object being created by the derived class. So for account object is easy because account object is only by itself. The data is there, but the employee and student and the work study, they kind of correlate depending on each other. Because if you create an object which is only employee, then you only need to know about employee account. That's the fundamental difficulty to make us to deal with this case. So okay, so let me actually first tell you where's the account object, because I said that's the simplest case. I'm going to use this box to help me to draw the what it is. Okay, I'm going to make it a little bit. Let me make it transparent so I can see that. Okay, make the wait a minute, where is it? Make it really thick and make it color to be green. Make it dark blue. Okay, and then I will make a dash here. Okay, so I'm going to use this to represent how I'm dealing with this situation. First, let's look at the address. So the address for the account, I just need to look at this part. This is account. There's one place that is the only information I need to represent the account object. And therefore, when you're pointing to the object, I just need to point the first byte of the object. Okay. So next time, let's actually look at the employee object. Employee object is a little bit complicated. because it actually really have two pieces. So one piece is this account, but the other piece is this part. So if you think about employee object, it really has these two pieces. And the thing is that if it's two pieces, I said, this is very different from multiple inheritance, where all the components within the same object are contiguous memory region. But here it's a separate. When it's a separate, it's like a linked list. That's why I need to have a virtual table pointer to implement that pointer concept for me to pointing to the other component. So that's what we have as a employee object. That's why employee object is always pointing to the first byte. So that's the employee situation. And similarly for student, and the student is basically the same thing, but it's actually this part. It's also two separate pieces. One piece is the student, one piece is the account. And also I need to have that point mechanism to link these two pieces of memory together. So that's for account, employee, and student. And for work study is simpler because the work study, the compiler there's no ambiguity that this is a work study. And essentially what I have, let me remove this. Then basically, I just include the whole thing. Okay, I include the whole thing. So therefore, the memory address is pointing to the first byte. So that's why in this scenario, the work study object is pointing to the first byte. Employee star is pointing the first byte. Student is pointing the first byte of this one, and the account is pointing at this. So that's look at the memory layout perspective for the objects. Then that's why it's actually you're seeing the result that you're seeing. Okay. Let me just make it a little bit better this way. Okay. So before I talk to a memory address for the member variable, any question?
Yeah, I have a question.
Sure, go ahead.
It's like the student will point to the virtual table above it, and employee also point to the virtual table above it. And then both of the two virtual tables will point to the account address.
Yes. This two virtual pointer is providing the pointer from the virtual table pointing to the account.
Oh, I see.
So the account become virtual. So essentially, it's like this. It's like this situation. It's pointing over here, pointing over here. If you see the value, actually, I did a layout. This is on my computer. When I print the variable, the value of the variable, each of the because each of this is 64-bit, right? And then I print the value of this. You can see that this is the value of the variable, but these two are the address in the virtual table. So by the way, my address for this part is like a 7 something, but my virtual table address is over here. And the virtual table address is, these two are different.
Okay, thank you.
You're welcome.
What about the orange part? What's the pointer point to the orange part?
You mean work study, right?
Yeah.
Because work study, this orange is kind of misleading. You have to see this. This orange area is just saying that where I'm going to hosting the member variable. Is not necessary just for the object. So each of the boxes is just represent the area of memory to support that particular portion of the object. Because work study, they really have all of them, right? Work study has student, has an employee, has account, right? I mean, work study has that part. So the whole thing I'm drawing here is considered the object area for work study. And therefore, the work study pointer is always pointing the first byte of the whole region.
Oh, okay.
Yeah. So that's why I want to differentiate this two. One is about the object, which object represents the whole thing. But the other one is the member variable. member variable, work study, this area has a member. So let's move to the next item, which I will talk about member variable. Then you can compare, and hopefully this will help you to understand this part as well. So I'm going to make a copy, and I'm going to use this one. So this is a member variable. So member variable, you can think about this way. I'm going to draw a box. I'm going to use a box. Where's my box? Somebody, if one of you working for Zoom, this is definitely something Zoom can improve. Okay, I'm going to use this as a variable. This is really variable, which is represent. Let me move this things a little bit further. This arrow just tell you the memory address relative. Okay, so this box, let me actually put the yellow. I like yellow color. Okay, so this represent the variable. And this is, each of this is 8 byte. I'm actually just write it down. Each of you in this case is 8 byte. Make it a little bit smaller. Okay. And the thing is that in virtual inheritance, I really have 4 of them. One is associated with employee. One of them associated with student. Of course, one of them associated with work study. And one of them associated with account. Okay, so you can see that each of the variable I have this 8 byte, and those variable I just want to tell you that what they represent is E1 first, and then you skip a pointer. I would say I'll just do this so you're not confused. The first one is actually a pointer. I call the vtable pointer. The second one is E1. The third one is virtual pointer. And then you have S1, and then you have W1, and then you have A1. Okay, so those are those 4 variables. Let me actually just put this into a different color so you will not get confused. E1, S1. So each of these 6 things I listed here is 8 bytes in the memory. All right, so this is a memory variable. Even though I said earlier, I said the whole thing represents the object of work study, but W1 really represents the portion of the work study objects that's actually being stored here. So this orange box, really it is storing the W1. So now if you look at this, and what is the memory address of each of the variable, you actually should see it here. If you see the memory address, if you do, let me just show you this here. If you do, for example, you do just example. If you do a AND E1, okay, this probably should be, assuming your pointer is WS, right? Sorry, it's the object is ws.e1. If you do like this, you put an ampersand here. That means the address of the ws of E1 is should pointing here because that address is here. So that address, if you see the difference, that should be 8 more than the pointer to the work study. And similarly, you can do the same thing for this. I'm wrong. Sorry about that. You can. This is tough for me. If you do S1, you're going to see here. If you do W1, you should see address here. And if you do the address of A1, I would say the address of A1, which is nws.a1, like this. This address should be equal to n, I would just call it, maybe use a different line. This should be the address of casting account star NWS. No. Is that right? Yeah. Sorry, I don't need this one. I don't need this in. Okay, so I basically look at the address of the WS, but I casting as an account star, then this two should be the same because I said the account star WS pointer is actually pointing to the same thing. So this side is the object address. This side is all the address to their member variable. So this is the comparison that why if you understand this, and you will see that their value, not just they have different addresses, but they have the difference between each of the pointers should follow this diagram for the case of virtual inheritance. Any question? Let me check the chat. Hold on 1 second.
Oh, Professor, could you upload the new slides? I mean,
Okay.
after this lecture.
Okay, I'll do that.
Thank you.
You're welcome. Thank you. Wait a minute. I didn't record? Did I record? Oh, okay.